In October 2024, a rocket tore through the Florida night sky carrying one of humanity's most ambitious questions into the darkness of space. Its destination was not Mars, not the Moon, but a frozen world nearly 800 million kilometers away, Europa. One of Jupiter's mysterious moons. Beneath its cracked surface of ice, scientists believe an ocean larger than all of Earth's oceans combined may be hiding. And now, something extraordinary has happened. Data from the Europa Clipper mission is beginning to return, and it may be hinting at something no one expected. Europa looks lifeless at first glance. A pale sphere of fractured ice, streaked with reddish scars that look like ancient wounds across its frozen skin. Temperatures here plunge below -160 degrees Celsius. Radiation from Jupiter's immense magnetic field bombards the surface relentlessly. To the human eye, it appears as hostile and dead as the vacuum of space itself. Yet beneath this frozen shell, scientists suspect a vast global ocean, liquid water trapped under kilometers of ice. Warmed not by sunlight, but by gravitational forces so powerful they flex the moon's interior like a beating heart. For decades, Europa has been one of the most tantalizing places in the solar system. The idea first emerged in the late 1970s when the Voyager 1 spacecraft flew past Jupiter and revealed something astonishing. Europa's surface was unusually smooth, almost devoid of craters. In planetary science, a lack of craters usually means something is constantly renewing the surface. Something moving beneath the ice. Something alive in a geological sense. Later, the Galileo spacecraft confirmed even stranger clues. Magnetic disturbances suggesting a salty ocean hidden deep below the frozen crust. But the real breakthrough came when scientists began studying the moon more closely with modern telescopes. They detected what looked like enormous plumes of water vapor erupting hundreds of kilometers above Europa's surface. Imagine geysers taller than Mount Everest blasting into space. If those plumes truly exist, they could be carrying material directly from the hidden ocean below. That means, without drilling through kilometers of ice, a spacecraft might be able to fly through the spray and analyze the chemistry of an alien ocean. This is precisely why NASA launched the Europa Clipper. Unlike previous missions that simply passed by, Europa Clipper is designed to orbit Jupiter and perform nearly 50 close flybys of Europa. During each pass, it will scan the moon with ice-penetrating radar, map the thickness of the frozen crust, and search for organic molecules within the plumes. In other words, it is humanity's first serious attempt to investigate whether life could exist in an ocean beyond Earth. The possibility is not science fiction. On Earth, life thrives in places once thought impossible, deep-sea hydrothermal vents where sunlight never reaches. Where organisms survive using chemical energy from the planet's interior. If similar conditions exist beneath Europa's ice, the moon could host entire ecosystems hidden in darkness. Creatures unlike anything we have ever seen. Life that evolved independently from Earth. But now, new measurements from Europa Clipper's early instruments are raising a chilling possibility. Something strange may already be stirring beneath the ice. And if scientists are interpreting the signals correctly, the ocean of Europa may not be as silent as we once believed. To understand why Europa has become one of the most compelling targets in the search for extraterrestrial life, we have to look beyond its frozen surface and into the invisible forces shaping the moon from within. Europa does not orbit Jupiter in a simple, perfect circle. Instead, its path is slightly stretched, an elongated orbit constantly pulled and twisted by the enormous gravity of Jupiter. Every few days, as Europa moves closer and then farther from the giant planet, Jupiter's gravity squeezes and releases the moon like a cosmic stress ball. This process is known as tidal flexing, and it generates astonishing amounts of heat inside Europa's interior. The moon's rocky core is slowly kneaded by gravitational forces so powerful they can fracture solid rock and melt internal ice layers. In effect, Europa is heated from the inside out, while the surface remains a frozen wasteland colder than Antarctica's worst winter. Kilometers below the ice lies a hidden ocean kept liquid by this constant gravitational kneading. Scientists estimate that this ocean may be between 60 and 150 kilometers deep. That is far deeper than Earth's oceans, which average only about 4 kilometers. In total volume, Europa could contain twice as much liquid water as every ocean on Earth combined. And where there is liquid water, energy, and chemistry, life becomes a possibility that scientists cannot ignore. But water alone is not enough. For life to exist, an environment needs chemical ingredients, carbon compounds, salts, minerals, and energy sources capable of fueling metabolism. This is where Europa becomes even more intriguing. Observations from telescopes and earlier missions suggest that the moon's icy crust is constantly cracking, shifting, and recycling itself. Enormous fractures spread across the surface like spiderwebs, some stretching thousands of kilometers. These fractures may allow oxidants and chemical compounds created by radiation at the surface to slowly sink into the ocean below. At the same time, material from the ocean may be pushed upward through the cracks. This constant exchange between surface and ocean could create a chemical environment surprisingly similar to Earth's deep-sea hydrothermal ecosystems, places where life flourishes without sunlight. But Europa Clipper was not sent simply to confirm that an ocean exists. Its instruments are searching for something far more specific, chemical signatures that suggest biological activity. As the spacecraft performs repeated flybys of Europa, its spectrometers analyze particles ejected into space by possible water plumes. These particles may contain salts, organic molecules, or even complex carbon chains, ingredients strongly associated with biological chemistry. And recently, something unusual has appeared in the preliminary data. Scientists have detected chemical patterns in plume material that do not fully match simple geological processes. The molecules appear more complex than expected. Not proof of life, not yet, but enough to raise eyebrows inside laboratories studying the data. There is another twist. Europa's ice shell may be thinner than previously believed in some regions, perhaps only a few kilometers thick instead of dozens. That means the ocean beneath might interact with the surface more frequently than scientists once thought. If true, the hidden ocean of Europa could be far more dynamic and far more chemically active. Which leads to a question that is slowly moving from speculation into serious scientific discussion. What if Europa's ocean is not just habitable? What if something is already living there? If life truly exists beneath the ice of Europa, the discovery would not simply be another scientific milestone. It would shatter one of humanity's oldest assumptions, that life on Earth is unique. For thousands of years, humans believed our planet was the center of existence. Even after we learned Earth was just one world among many, we still held onto a quiet hope, or fear, that life might only have emerged here once, by a rare cosmic accident. But Europa challenges that idea in a profound way. Because if life evolved in the dark ocean of a distant moon, then biology may not be rare at all. It may be a natural consequence of the universe. Imagine what that would mean. Beneath kilometers of frozen ice, in total darkness, an entire alien ecosystem could be thriving. Microbes drifting through warm ocean currents. Strange organisms clustering around hydrothermal vents where mineral-rich water pours from Europa's rocky core. Perhaps creatures adapted to crushing pressure and perpetual night, sensing the world through chemistry instead of light. None of this requires sunlight. On Earth, entire biological communities already exist in such conditions. The difference is that Europa's ocean has been sealed beneath ice for billions of years. Isolated from the rest of the solar system like a hidden laboratory of evolution. The implications grow even deeper when scientists consider how stable Europa's ocean might be. On Earth, environments constantly change, continents drift, climates shift, oceans circulate, but Europa may have maintained a stable ocean for over 4 billion years. That is nearly the entire age of the solar system. A world where life, if it began, could evolve uninterrupted for immense spans of time. In that sense, Europa may not simply host life. It could host life that has followed a completely different evolutionary path from anything on Earth. And if life exists there, another realization follows immediately. Europa is not the only ocean world. Across the solar system, several icy moons appear to hide global oceans beneath frozen shells. Saturn's moon Enceladus ejects enormous plumes of water vapor into space. Titan contains lakes of liquid methane in a complex organic atmosphere. Even distant dwarf planets may conceal subsurface oceans warmed by internal heat. Suddenly, the solar system begins to look less like a collection of barren rocks, and more like an archipelago of hidden oceans. That realization changes the scale of the question completely. Because if multiple ocean worlds exist here, around a single star, then similar environments may exist around billions of stars across the galaxy. The Milky Way alone contains hundreds of billions of planets. If even a small fraction possess oceans like Europa's, the universe may be filled with countless biological worlds quietly evolving in darkness. But perhaps the most powerful implication is philosophical. Humanity has always searched the sky wondering if we are alone. For generations, the silence of the cosmos has felt immense and unsettling. Yet the answer may not lie on distant planets with blue skies and alien forests. It may lie hidden beneath ice, in oceans we cannot see, on moons we once dismissed as frozen wastelands. Europa reminds us that life does not need paradise to exist, it only needs possibility. And somewhere, far beyond the warmth of the sun, beneath a silent shell of ice, an alien ocean may already be alive.